Good morning, and thanks for joining today's broadcast on how Malwarebytes transforms vulnerability telemetry with Redis Enterprise. Today, we'll discuss Malwarebytes' use of Redis Enterprise to collect millions of malware data from across the world to power real-time visualizations on global threats, attack vectors, and malware. Our presenters today are Darren Chinen, Senior Director of Data and AI at Malwarebytes, and Priya Balakrishnan, Senior Director of Product Marketing at Redis Labs. Darren has implemented big data solutions on Hadoop at GoPro and Apple. Living in data for almost 20 years, he cut his teeth as a data engineer on traditional data warehouse technologies and has led EDW transition projects to Hadoop as well as new big data implementations. Priya brings more than 18 years of enterprise technology experience to her role as Senior Director of Product Marketing at Redis Labs. She joins us most recently from Splunk, where she spent over 6 years as the head of Splunk's product marketing for IT operations. Today's webinar is being recorded and all attendees are in listen-only mode. During this webinar, we will be taking questions during the Q&A session. You can post your questions using the question and answer module in the communication panel. Following today's webinar, an email with the link to the recording will be sent to you for future viewing and to share with your colleagues. And with that introduction, Priya, the floor is yours.
Thank you very much, Jean, for that introduction. And thank you all for joining us today. In today's webinar, we will be going over very quickly an introduction to what Redis and Redis Enterprise is. And then I will hand the control over to Darren, who will go into great depth into why within his organization he decided to go forward with Redis and Redis Enterprise, and how he uses Redis Enterprise within his organization across a variety of use cases and really transforms the way that they're able to deliver solutions to help detect malware as well as provide security solutions. And lastly, he will also cover about his various use cases on how he uses Redis as a primary data store. So let's dive right in. So quite a few of you here are actually familiar with Redis, but I'll give you a 30,000-foot introduction into why Redis was voted as the most popular database by over 100,000 developers earlier this year by Stack Overflow. Redis is extremely well known for its performance, simplicity, and extensibility. So let me explain. So if you look at performance, if you look at this chart on the left, in this benchmark, what we actually measured were a high volume of writes where we're pulling applications, and we measured the end-to-end latency. And as this chart indicates, Redis outperformed all the other databases, including Couchbase, Cassandra, and DataStax, where we were able to deliver almost 8 times higher throughput at 1/4 the latency. Additionally, on this chart on the right, what you are able to see is an article that was actually published on the Google blog, and this benchmark compares the various solutions on what it would take to deliver 1 million writes per second. And Redis can get you to 1 million writes per second with the fewest resources. With Redis, you can see here that we only need 2 server instances when compared to the 300 plus server instances needed by Cassandra. So what we're able to essentially do is give you the sub-millisecond performance that is extremely well known for, with the largest throughput and with the least amount of resources. The second reason why we're extremely loved is because of its versatility in data structures. This is actually very, very important because what we do is we support a variety of different data structures like strings, sets, sorted sets, geospatial indices, bitmaps, lists, and much, much more. And what this means is that each of these data structures actually come with its own set of built-in commands to perform even very simple operations in memory and also make data processing significantly faster. So many of our customers love using the versatility of data structures. You'll also hear Darren talk about it a little bit. But for instance, if you look at Freshworks as an example, they became very popular most recently with their campaign at against Salesforce. But if you see, they actually use hashes, lists, and sorted set data structures to meter the API requests that are coming in. If you look at dynamic yield as an example, they index the personalized settings of their end users and store them in these data structures within Redis to drive more personalized experience. So truly the versatility in the data structures is another huge reason for the growing widespread adoption. The third reason why our users love us is its extensibility with modules. These are add-ons that actually sit on top of Redis, and they extend Redis to cover the most popular use cases as well as custom data structures. So what they do is they seamlessly plug into Redis and are processed in memory, and they extend all the simplicity and performance that we talked about to these custom use cases. We have a variety of Redis modules that we publish. Redis Search is an extremely popular Redis module. Again, Darren will talk a little bit about it, but it essentially allows you to perform complex aggregate queries very, very easily. We also are going to be announcing our support around Graph, which allows you to extend Redis as a graph database. We also already include JSON module, which allows you to extend Redis as a document store, or we have the ML module that implements several machine learning models as Redis data types and others as well, right? So what this means is that this truly extends Redis into a multi-model database. And as a result, what we are seeing is that we're able to power a variety of different solutions. So we have, from fraud detection to e-commerce to personalization to IoT and metering. So as an example, Home Depot actually uses Redis Enterprise for metering and throttling the number of requests that are coming in so that their application doesn't keel over and that their application is able to handle the load without any impact to performance. Right? If you look at Microsoft, they actually use Redis Enterprise to power personalization with their MSN services. If you look at Innovonics, they actually use Redis at their IoT edge devices to collect all of the data from millions of sensors to power real-time analytics with Redis. And so what we're seeing as a result is that our customers, while we did start off as a caching solution, and that's what we're extremely very well known and popular for, what we're seeing is that our customers are actually really maturing in their adoption and usage of Redis Enterprise, and it can be used across a variety of different use cases. Our most popular use cases, of course, include high-speed transactions, user session store, message queuing with PubSub, search, fast data ingest, and caching. But in addition to that, we also support things like time series, like geospatial indexing, machine learning, graph, and so on as well. So far, we've talked about Redis. So what is Redis Enterprise, right? So Redis Labs as an organization is the home to both Redis open source, which we are the developers and contributors for, where we have a dedicated team that does that. But we also bring Redis Enterprise to the table. So think of Redis Enterprise as this wrapper around Redis open source. So when you need to go beyond a single instance, when you need to automate a lot of the operations, Redis Enterprise is the solution you're looking for. It combines your Redis instances and it creates a pool of memory. We also have a zero latency proxy. This way you can direct all your requests to one endpoint, and we will figure out within Redis Enterprise on how to distribute that request across the various shards and the nodes you have within your clusters. The other thing we added is a cluster manager to manage the pools of Redis resources that you actually have. The REST API is used for management and monitoring of Redis Enterprise. And what really makes this also additionally powerful is that it's actually a multi-tenant node. So here as an example, you can see that there are multiple tenants of Redis instances within a single node that really allows you to maximize the infrastructure that you're actually provisioning for within a single Redis Enterprise node. And this is actually very powerful and differentiates us significantly from how Redis open source technology actually works. Secondly, we also maintain persistency, right? Redis Enterprise adopts a shared nothing symmetric architecture and makes sure that the data path actually faces no obstruction. So despite the cluster management feature and despite adding all of these additional capabilities, we're not only able to deliver separation in data, but we're also able to maintain the performance that we're well known for. That means that we're adding no overhead with all of these additional operational capabilities that we're actually adding onto Redis. We also have watchdog capability. So we have the cluster watchdog, we have the node watchdog, and this allows you to basically monitor the state of your Redis instances and automatically and automatically distribute the load and manage the load balancing. And this means you can have more than one instance with lower latencies. We're able to shard and transparently transfer control, and we're able to maintain the health of your Redis implementation or your Redis Enterprise implementation with no overhead whatsoever. In addition to that, we also have additional capabilities that we have added, that really simplify application development and deliver to high availability. So as an example, we have active-active geodistribution. So this is, the active-active geodistributed topology is achieved by implementing something called CRDTs, that's conflict-free replicated data types. And this is actually a unique way to actually provide the fundamental benefits over other geodistributed solutions, where it offers local latency on both read and write operations, regardless of the number of geo-replicated regions and their distance from each other. It enables very seamless conflict resolution. It's conflict-free for simple as well as complex data types, like those that are of the Redis core that we just discussed. Even if the majority of the geo-replicated regions in your CRDB are down, the remaining replicated regions are uninterrupted and can continue to handle the read and write operations with local latency. So it's actually extremely powerful, and we're seeing more and more customers adopting Redis Enterprise, for the active-active geodistribution that we're delivering with our unique CRDT-based approach. The other thing we also have is Redis on Flash, where we provide you the ability to extend Redis to a combination of Flash as well as RAM. So what we do with this technology is that we store the hot keys as well as the values in RAM, as well as, and then move the cold data and the warm data onto Flash SSDs while still maintaining the keys of those, cold and warm data in RAM. So if at any point in time you want to pull that data from your warm buckets onto RAM, we can easily deliver with sub-millisecond latency, right? And why this is powerful is that now you're not constrained by the amount of data or your RAM utilization, where you can really optimally use your RAM for all of the hot data, but move all of the, and significantly save in infrastructure costs. So as an example, White Pages, and I have a subsequent slide on that, saved over 70% of their infrastructure costs, of their AWS infrastructure costs by using the Redis on Flash technology. You will see Darren discuss that a little bit as well in subsequent slides. Redis Enterprise is growing very, very fast. We have over 8,500 Redis Enterprise customers. We have multiple deployment options where it's available on premises. It's available on any cloud of your choice. It's available on PCF and Red Hat. Earlier this morning, we announced our availability on the OpenShift platform as well. And we're also available as a managed service. And you will see that, some of the largest organizations, 6 of the Fortune 10 companies, 3 of the top 5 communication companies, the top 3 of the 4 credit card issuers, and the top 3 and the 3 of the top 5 healthcare companies are actually using Redis Enterprise. And here are some customers on how they're using it. So I talked a little bit about White Pages and how they've been able to they migrated from Amazon Elasticache. They actually evaluated other solutions like MongoDB, Apache Cassandra, and Couchbase. But ultimately, none could handle the full data set size, that they were looking at, and still provide that single-digit latency while also delivering the cost savings that they were actually looking for. And with Redis Enterprise and Redis on Flash technology, they actually were able to not only get the performance that Redis is well known for, they were also able to save on infrastructure costs. Of course, you will hear from Darren who will talk about how they use Redis Enterprise within their organization. We have Microsoft as an example where they use us completely for their MSN service, and where, as an example, on election night, they were able to cater to over 2 billion users without any downtime using Redis Enterprise, right? So we have a variety of different customers and use cases that's all available on our website. With that, I'm actually going to transfer the control over to Darren, but before we do that, what you will see is a couple of polling questions pop up. It would be great if you could just take a few seconds to answer these questions, these polls, because this will allow us to understand, why you're interested in this webinar, and also try to understand, how you're actually what you're actually looking to learn from this webinar. And with that, we will be able to transition the control over to Darren and talk about his use of Redis Enterprise within Malwarebytes.
Thanks, Priya. I'll give you guys a couple of minutes to fill out those surveys. Okay, shall we continue? I'm going to go ahead and continue.
Okay.
I'm going to talk a little bit about my area, which is web, data, and AI. Those teams report into me. And we've done some pretty cool things with Redis. And so I'm going to kind of go into that a little bit. Let's see here. Uh-oh, I'm losing control here. Priya, are you able to click your mouse for me?
Unfortunately not. I don't seem to have control either.
There you go. All right, let's see.
Okay.
Let's see if I got that back. There you go. All right, so a little bit background on me. I spent time a lot in the coming up the ranks as a data guy. Most recently, I worked at Apple and then Roku and GoPro, and now I've been here at Malwarebytes for a little over 2.5 years. It's been a fun time. I want to talk a little bit about Malwarebytes. Malwarebytes was founded by a guy named Marcin Kleczynski. He was actually a 14-year-old kid playing video games and had downloaded all kinds of mods, and in that process got some malware to infect his machine, and he was very, very disappointed at 14. Went out to the web. He found some people that were willing to help him clean his machine before his parents killed him, and those people actually, to him, were his heroes. They kind of ended up banding together, and he ended up writing his first piece of malware disinfection software at the ripe old age of 14. By 18 years old, he had founded this company, Malwarebytes, and went off to college for 4 years, came back and resumed his duties at 22, and now at the ripe old age of 28, he still is on this mission where he believes that everyone has a right to a malware-free existence. He's an amazing guy. That was him doing a TED Talk. He has talked really about driving home that we really want to create the best disinfection and protection solutions to combat the world's most harmful threats. We started off that mission initially serving individuals, consumers, and since then, Marcin has really expanded the vision to include enterprise and really protect entire businesses and companies. So we actually have both the business and the enterprise as our customers. And that's actually important because the business consumer is way more sophisticated than sort of the home user. So we've had to kind of up our game. And that's really where Redis has come into the picture for us. Redis Enterprise has really given us an unfair advantage. really when dealing at an enterprise in a much more sophisticated level. That's really the reason why I was hired. So before I get into like architecture and stuff like that, I thought I'd show you a couple of examples of where we're using Redis, a couple of cool places that have some visual flair. The first thing is that I'm going to show you is something called the Omni portal. Now this portal is basically a combination of a sales tool that we give to our sales agents, and they're able to show this tool where we harvest anonymous telemetry where we know we're installed alongside another vendor like AVG, antivirus. And when we're installed alongside, we can actually tell where they failed to catch a piece of malware and where we had to clean up. So I'm going to show you that side here. You can see a list of vendors. This is vendors where we have a sample because we're installed alongside. And if you look at AVG, we can see that the failure rate, at least on the machines that we're installed on, is about 30-something%. And it even is some nasty stuff like ransomware that you can see. We've actually gone in and remediated for. This is a leaderboard, what we call a leaderboard. These are pieces of malware that we are remediating or protecting against that AVG is missing. So this kind of shows us the trend of what AVG is missing at any given point in time. The other thing we're able to do is we use Redis to cache the last 7 days of misses by AVG or any other vendor that we're sort of tracking against. And this is a very powerful tool because we can sort of show a DVR fast forward playback of all of these things that we've really had success catching where AVG has missed. The other side of this portal is called threat intelligence, and this is really where we don't really focus on any particular vendor, but this is just all of the data that we have. We have hundreds of millions of installations that are pouring data into us, depositing data in an anonymous fashion, and we're able to get sort of real-time eyes on the ground in terms of what is actually trending. And this is really just storing counts, but you can see how powerful this leaderboard is to understand velocities. I've filtered by Germany here, and I'm going to show you that we've cached this data in Redis, and so what we can do is go back in time, mine through that data, and show you how WannaCrypt, this particular nasty piece of ransomware, has really propagated throughout the country of Germany. And it's pretty powerful to be able to visualize that stuff because as you'll see, you can go back and it's quite interesting. If you actually do the same thing and you zoom out to a global level, the picture is quite different. And I'll kind of show you that as well here. So this is WannaCry or WannaCrypt. And this is actually how we saw that it infected the world. Most malware has a gestational period, and that's actually what you saw. That was really one of the first things we were able to determine once we started building these maps. It takes them about 35 days to 60 days, a malware creator, to sort of unlock what's going to trick people. And once they get that, then they sort of got you. The last thing I'll show you is some real-time detections, and this is where we basically grab data. It comes in real time as we're finding it. We actually use Redis as a stateful store to enrich the data in real time, and we're able to plot that on a real-time map. Kind of going further on that, I wanted to show you a very interesting one because this is where sort of threat intelligence comes into play. For not only internally, but we can actually show customers a very interesting look. This is a ransomware called Petya, and Petya it's kind of an old one. You can see 2016, but this one had a very, very different type of attack vector. And you can see that what'll happen is when I hit play, you'll see that Petya, it goes through a gestational period of about 60 days, where we see it figuring itself out in the country of Germany, and at about day 50 or 60, they figure out the key, they unlock it, and it goes global. And that's what you see right there, right? You can kind of see that this whole Petya thing went global. Once it hits, people figure it out, they forget about it, and about a year and a half, about half a year later, you'll see that they'll go on another attack as well, and you can see that it'll kind of spray at the end here. This is a kind of a cool thing where what we've done is we take real-time detections and we cache them for a period of 2 to 5 minutes, and in that period, you're actually able to see or do searches on any of the real-time sort of last 2 minutes of data that we saw. And that one I was kind of showing how you could pick out the ransomware detections over the last couple of minutes. This is the same thing, a leaderboard, but this is something that we would provide to our research team. And this allows them to see the velocity of malware so that they can kind of bubble up the ones that they want to pay attention to and keep an eye on for that particular day. All right, so let's get into Redis. That was some kind of cool use cases of how we're seeing Redis being used today. And I want to talk a little bit about our thought journey between, we started off using Redis, I think like many software organizations, as a cache. And as we got into it, we began to see it a little bit more as a primary database. So let me kind of talk about that. When I say cache, what I mean is we really thought of Redis very similar to, I use this jokingly, I say, it's sort of like the cache of water that you keep on your bedside table because you don't want to get up and go to the kitchen to get another glass of water in the middle of the night. It's just something that's small, it's disposable, you can refill it. It's definitely not the source of truth, right? And that's really the way that we started using Redis, which was just to cache things like JWT tokens and sessions. And it was a convenience, it was a performance booster, but it wasn't critical. And if we lost it, it wasn't that big of a deal to like let it build up again. Well, a database, that's where we had to go through a couple of mental and logical leaps, right? And that is something where we had to be able to see Redis as reliable. We had to make the transition of seeing it as a source of truth. And it also, because it was powering visualizations and threat intelligence, it had to be highly available. All right. So the first thing that we needed to address was sort of performance at scale. So I want to give you a couple of numbers to just give you an idea of the scale that we were dealing with. We get about 1.2 billion request packets per day, and these are sort of packages of JSON messages sort of in an array that are packed together. We have to break those apart. It goes through a number of different stream processing engines as well as batch processing, and then it takes a couple of different paths. By the time we're done with it, at the end of the day, we end up processing about 500 billion records in order to drive insights. We actually persist in our data platform across Redis and other places that we store data about 2.5 trillion records. We've accumulated that over about the last 24 months. And right now, we have about 76 petabytes of data that we're storing. So that's kind of part of the challenges that we're dealing with. And like all big data implementations, part of the problem is that you're dealing with large, unstructured, or loosely structured data. And it really takes a lot of sophisticated systems and processing in order to get to something that's more structured, that's highly efficient, that makes sense, that can drive insights in a performant way at the UI. This is a little cartoon drawing. I have a little disclaimer there that says cartoon drawing, but just so you guys know how we approach this, we actually, this is not very accurate, but we basically, if you look at the top, we have a streaming ingestion, we have stream processing, we use Redis as a stateful store because we use that for things like streaming joins. For real-time stuff. It goes into a set and accesses a set of web services. We cache a lot of the data, as you saw, to power those visualizations. There's also batch data processing. There actually is an arrow going from batch data to some of the data caching as well, but I think that got blacked out. And then we are able to serve up web applications, and we also do studies and dashboards and machine learning as well against all of this data. So a quick thing, I just wanted to talk about performance at scale. And this is really where, at least for us, we started thinking about Redis Enterprise. So if you believe in IBM's big data, in the 4 V's of big data, those 4 V's are veracity, variety, velocity, and volume. And so veracity, that's really just data quality that has to be addressed in pretty much quality assurance or QA. Variety, when we were doing some POCs, Redis, open source Redis was fine. It actually did great. It handles all kinds of different data types, and the data structures were amazing. But where we started having issues is in the velocity and volume area. We just couldn't fit all of the data onto a single instance or a single node. And that's for us where volume and velocity really had to be addressed with the power of the clustering of Redis Enterprise. I can talk to you a little bit about how we got there, but we did actually try doing this clustering and doing all of these things with open source Redis, and it turned out that Redis Enterprise had actually solved a lot of the problems that we were spending a lot of engineering time on. The other thing with seeing this as a really a primary database to power some of our key visualizations and threat intelligence was that it had to be highly available. And one of the things that the engineering team said to me is they said, you know, Redis doesn't fail, but our problem is that, you know, what we notice is that the hardware does. And so we needed things like to be able to replicate our databases, right, have HA. We needed to get larger, more complex, business critical stuff in there. And we also started looking at, which we are today, the geo distribution, where we do actually have a cloud offering which powers our enterprise side, and we will actually be leveraging some of the geo distribution that Redis Enterprise can offer. I'll talk a little bit now and shift to some of the use cases that we're working on right now, because I think it's interesting. So in terms of Priya mentioned Redis on Flash, and I think this is a really interesting one to talk about because Redis is ridiculously fast and ridiculously powerful with its key data structure format. All of our engineers love it, but the problem is that as you start getting to larger data sizes, it gets very expensive. And so we were using things like Elastic Cache on AWS and Elasticsearch, and we ended up being able to move a lot of that to Redis Enterprise, combination of Redis Enterprise search as well as Redis Enterprise on Flash, and we were able to achieve about an 85% savings. There is a slight performance degradation, but it's not noticeable in our dashboards. I mean, when we say performance degradation, it's like, you know, a few milliseconds. So it's definitely acceptable for us for our visualizations and for our tooling, and definitely worth the savings. The other thing that we started looking at was a document store. We do a lot of, you know, we sell software, so there's licensing, and we also have to do identity management. And we started looking at other tools like Couchbase and MongoDB, and we really just loved the speed of Redis. We loved how flexible Redis was. The team, by the way, it's not written here, but the Redis Labs team is very engineering focused. They're not the typical IT software vendor, and they were willing to work with us on a lot of solutions. So this is something we're actually implementing right now, which is a document store which implements the module of read.json. And of course, our data sizes are so large because we have a freemium offering. We're talking about hundreds of millions of records that we need to basically manage, and in some cases billions. And this is a very cool move for us because we were able to implement things really in native JSON. We didn't have to translate this over to any of the native Redis data types, and it's really been quite a big win for us. The other thing that we've done is we wanted to investigate using doing behavioral detections or behavioral investigation using Redis search. So the original behavioral detection and investigation, I should say, was really based on Elasticsearch. And the problem with that is that everything on that is stored in memory, and it's also constrained in terms of I/O, like how fast you can index things. Redis Search actually removed that, and we worked very heavily with the Redis Labs engineering team on a pretty cool, innovative, and cost-effective solution where we were able to leverage not only Redis Search, but also Redis on Flash. So we talked about a solution, and we've actually implemented it, where we are able to store the data on Redis on Flash, which is a much more inexpensive, probably 15 times cheaper, right, to store data there. And we just ended up storing the indexes on Redis Search, and then we use Java to sort of coordinate between the two. But it's been a huge win for the team as we've implemented this, and more and more as we deal with this unstructured data. Search is becoming really a focus area and a centerpiece of our architecture, and we really needed a way to provide fast and performant search across large amounts of data, but it had to be cost effective. So this is a very, very big win for us. The last sort of use case I'll talk about is the concept of whitelisting. And for whitelisting, what this is in AV speak, or antivirus speak, is it's a false positive. Now, a false positive in AV would be if you have a good file, let's say a good system file, and for whatever reason, we accidentally identify it as malware and we quarantine the file. Worst case scenario is it bricks your machine. You can't even reboot your machine. We used to jokingly call this system MEPS, which stood for Malwarebytes Extinction Prevention System, because they say in our business, a bad false positive can literally put you out of business if you bring an enterprise to a grinding halt. So our goal was to keep a whitelist of all the known good system files. The problem is, you can imagine, there's a huge amount of them. It takes a lot of space. And that's one of the reasons why we decided that we wanted to use Bloom filters. So we started experimenting with Bloom filters, and we realized, for those of you who don't know, Bloom filters are really just a space-efficient way to sort of probabilistically sort of determine the existence of a file. And you can go look that up on Wikipedia, but suffice it to say, what you do is you take a file, you hash it using, let's say, 3 or n number of different algorithms, and you sort of store those, the output of those bits. You turn those bits on, right? You can kind of see by the illustration below, which I lifted off of Wikipedia. And you're actually able to sort of check whether a file exists. Now, based on that, false positives are actually possible, although it's rare. And what's pretty cool about Redis is that we were able to actually tell Redis, when implementing a Bloom filter, how many elements we anticipate storing, and what is our tolerance for FPs. And Redis will actually determine the number of algorithms and the number of bits that you need to set up your Bloom filter. It also handles stacking, beautifully. We don't have to do anything there. That's automatic. The other cool thing about Bloom filters is that false negatives are impossible. Just by the way that the algorithm works. So that has been a huge win for us, mainly because we're not implementing one Bloom filter. There's not one whitelist. There's whitelists not only for like global whitelists, but we have whitelists down to the company level, down to the policy level. There can be whitelists for specific machines. So you can imagine there's many different Bloom filters that we need to capture and maintain at any given time. And Redis Enterprise helps us to scale out and do that. So on our future roadmap, one of the things that we're experimenting and working with Redis Labs on is really using Redis Graph. And the talk was to do an asset relationship mapping, where we were able to see the relationships of computers and their software, and this could really help us in determining, hey, this machine got infected. What are all other machines sort of related or sort of like it? And that's sort of a great way, if you will, to sort of put out an Amber Alert, right, to our customers and say, hey, these are the machines that seem to sort of be like this other machine that got infected. Well, we put together just a sample graph application to show you how this might work. This is called, this is just a pretend thing, but I mean, it's some sample data that we pulled. This is called the MD5 and Rule Graph Explorer, or MARGE for short. And what we did was we said, the way that we used to detect malware was based on a rule. So you can imagine if you had the largest email inbox in the world and it had millions and millions of email, and your job is to clear those email out. You might go in there and create some rules in your Outlook filters or your Outlook rules, and you could clear out large amounts of email just by rules. That would work great if that was just you, but imagine if you had an email clear out team. You have a lot of cooks in the kitchen, and it turns out that rules can at sometimes overlap, right? Maybe one person says anything that's from, any email that's from X sender, remove it, and someone else says any email that's written in red ink, and it could be that both those rules catch the same thing. So I'll show you a little bit about how we've done this. We built this sample application to talk about how our rules catch MD5s, or MD5s is kind of how we refer to a specific piece of malware. We put this into a graph database, and you're actually able to see that a lot about this particular piece of malware and the rules associated with it. Again, this is just a little sample application, but this is an idea of how we might use our graph database for sort of asset and relationship mapping. Here's an idea of a particular rule. It's catching, as you can see, 3 different pieces of malware. Those 3 pieces of malware are caught by this other rule, which catches not only those 3 pieces of malware, but a lot of others as well. And in this application, what we do is we can actually test removal of a rule by just removing that node, and you can check to see if any of those blue malwares are orphaned, and they're not. You can see they still have lines back to another rule. So this is kind of a little cool, like a prototype that we built. We went the extra mile and hooked it up to VirusTotal to see what exactly that piece of malware was. But that's just a cool example, maybe, of how we can use kind of a graphing database and for some pretty powerful malware applications. Last thing I'll talk about is behavioral AI detections. Our intention is really to migrate a lot of things over to Redis machine learning. We set up an experiment and analysis on doing some detections. One of the first things that we needed to do was do some cluster variants, pre-clustering, and we created a couple of variants, and we're able to see where sort of machines are sort of similar to each other. And without giving away too much, because this is sort of going into some of our detection technology, we used machine learning to basically determine these variants, and then our intention is to actually run a bunch of data based on these one of these 2 variants of clustering to actually do some behavioral detection. So that's a little bit about what we're doing. That's our future roadmap. I'll just end with this. The team kind of, we talked about it, and they said, after you fall in love with Redis, we wanted to use more of it. We really wanted to throw bigger data sets at it and not actually have to worry about failure scenarios. So the engineering team, to get open source Redis to replicate data, persist data, and backup data at scale, it turned out for us to be a much bigger engineering effort than we originally anticipated. We quickly found ourselves in the weeds engineering Redis scalability and durability instead of spending time actually building the product. And that was just a quote that the team kind of gave me to kind of share with you guys. And that's really the story for us in terms of Redis Enterprise and how it was a win for us to go from just open source Redis and Elastic Cache to Redis Enterprise. So with that, I'll open it up to some Q&A. And I think, Priya, maybe you want to
Yes, and
take over.
Thank you, Darren, and thank you for the great presentation and the ending with a great quote on why, what some of the benefits on Redis Enterprise is when compared to, open source Redis or Elasticache. Before we do jump into the Q&A section, what I'd like to do is just very quickly go over a poll. There were a lot of things you specifically covered today, and I think it'd be great to just get an understanding from the audience on, what areas or what topics were of the most interest to them. So if you could just take a few seconds to answer this poll, while I think Jean goes into the Q&A section, that'd be awesome. Thanks, guys. Jean?
Great. Yes, so at this time, we're going into the Q&A section. As a reminder, please enter your questions in the questions section on the GoToWebinar control panel. And the first question we have is actually for Darren. So why did you choose Redis Enterprise over Elasticache? Was it worth the pain of having to maintain the cluster yourself?
That's a great question, and that was a question that we actually struggled with, quite frankly, with our DevOps team, right? Because DevOps guys, they love Elasticache, and we had to sort of convince them that Redis Enterprise was really a great move for them. It turned out to be a great move because as we got into more sophisticated data sets and larger data sets, it couldn't really be managed in Elasticache in a cost-effective way or an easy way. And so it turned out that the management of all of these different Elasticache instances and just the cost that we were incurring to store all of this historical data in there was really the driver to move towards a clustered approach to Redis Enterprise. And to be honest with you, once we got past that battle with the DevOps team, they came back and thanked me. They loved it. They said, wow, this is actually really, really easy. We actually like the aspect of just running one cluster. The console to monitor this is quite easy as well. So it turned out to be a bit of a struggle, like in terms of like mentally convincing people. But after we got through all of that, I think the team is pretty grateful, and it's really been a low maintenance effort for us.
Great, thank you, Darren. We do have a couple more questions for you. And the next one is, you already used Redis as a cache, and it works well. You talked a little bit about the volume, velocity. In what other ways does Redis Enterprise help you?
Well, I think Redis Enterprise, I mean, aside from what I talked about, I think those are the things that I would say are the key points, right? Is like when you're starting to deal with larger data sets, it's very, very difficult to scale up open source Redis, and I think that's the big driver. And then the second thing is that Redis, for most companies that are just starting off with Redis is like a sort of a background helper cache, and that's where it was for us. So we didn't put much thought into hardening up Redis because it was just doing things like caching JWT tokens, and it's fine, right? Like if you lose it all, no big deal. The users experience a little bit more latency because now we have to make a round trip to to an external API call or server. But Redis Enterprise, it's really helped us to change our mindset, and it allowed us to think about using Redis as a technology to power front-end mission-critical applications, which we wouldn't have done on just open source Redis. I hope that answers your question.
Great, and then maybe get a little bit into it again. You mentioned that your team loved Redis. Can you talk a little bit more about why Redis was even adopted before Redis Enterprise within your organization, and why was that adoption so rampant?
Sure. Redis is, I think most software engineers love Redis because mostly because of the data structures. It's ridiculously fast. But where software engineers love it is the key data structure, the key and data structures that you can implement in Redis. So if you look at other sort of key value stores, you're really storing a string value, and then it's on the engineer or the developer to get that string value, parse it, and then do something with it, and then go ahead and maybe replace that whole string value. So there's a lot of work up front, and it's also, adds not only coding but latency. Whereas a lot of that work for our engineers could just be moved into the Redis native data structures. I mean, things like just lists and sets and hashes. Those are things that I think almost all engineers, they understand because they're data structures in most languages, that really just translated to beautifully to when we started working with Redis. It was just something that they understood, and the amount of code that we had to write to parse through things and to update values was taken care of for us.
Great, thank you. And then maybe one more question. You mentioned your use of Redis search, and I was wondering why did you not consider other options like Elasticsearch or Splunk?
Well, as I said before, with Elasticsearch, we actually did consider that. That was actually our initial choice. But what happened was with our data sizes, Elasticsearch became very, very expensive. And the other thing that we found was that it was I/O bound. So at the rate that we were trying to index data, we saw that in the future there was actually going to be a bottleneck that we could not physically overcome. And so that was the first driver. But the second thing was that it's 100% in memory, and so it ends up being a very, very expensive proposition if you're dealing with large amounts of data. So that's where, for us, working with the Redis Labs engineering team, we were able to come up with a pretty cool solution where we were able to store the indexes only in a very small in-memory Redis search cluster, or relatively small compared to the whole data set. And all of the actual data was stored in a Redis on Flash cluster. And we just had a little bit of work to coordinate those two clusters together. And we're able to provide very fast real-time search at a very cost-effective manner. So yeah, so the answer is yeah, we went down the path of most organizations, and we did try Elasticsearch on AWS. And we ended up having to transition out of that for not only for cost reasons, but for scaling reasons and performance reasons as well.
Great, thank you for answering all those questions, Darren. Well, that's actually all the time we have for questions today. So I want to thank you again, Darren and Priya, for presenting. And also, before we go, I'd like to invite everybody to our next webinar with Roshan Kumar, Product Marketing Manager at Redis Labs, who will be discussing how to design, develop, and test applications using CRDT. The registration link to this webinar is now open on our website. And on behalf of the entire Redis Labs team, thank you all for joining us today. We're at the end of another webinar. An email with the link to the recording will be sent to you for future viewing and to also share with your colleagues. Join us next time. So go to redislabs.com/webinars and check out what's on top and register. Thank you all again for attending.